Okay, shall I start now? So, lift as well as the weighing machine, we will learn these two concepts in a single shot only. Okay. Now, why we are discussing this weighing machine as well as the lift? Okay, I think you guys have experienced this. Consider there is a weighing machine and a person is standing on a weighing machine. Consider his mass of the body or the mass of the person is 100 kg. Okay, and the weighing machine displays what? Mass or the weight? First thing, will it shows 1000 Newton or 100 kg? 100 kg, yes or no? 100 kg is mass or 1000 Newton is mass? 100 kg is the mass. First thing, weighing machine shows the mass. It doesn't shows what? Weight. Yes. But if we are saying that weighing machine is showing the mass, if it's showing the mass of a body never changes. We already know that. Yes or no? Now think like this. Consider the same person, 100 kg man who is standing on the weighing machine. He started to move on the weighing machine itself. Okay, suddenly he's sitting over there, or suddenly he jumped, or suddenly he's standing on a single leg. What you experience is that, what you see, that there is a change or there is a variation in the mass which is being displayed on the screen. Yes or no? This everyone has experienced this. So, mass of a body, we know that never changes. Mass of a body never changes. But it is showing what? Variation in the mass. So, in reality, we need to understand what do weighing machine in reality measures. If it is measuring the mass, then it should not be showing the variation in mass. Yes or no? It doesn't show obviously what? Weight. That means it doesn't measure the weight also. Yes, first thing, weighing machine never measures mass, nor it measures what? Weight. It shows mass, but it never measures mass. Okay, one thing. And let me introduce about the lift also. Consider a person, same person, 100 kg mass, who is standing inside a lift. When the lift is moving in the upward direction, what he experiences is, he feels that his mass got increased. He experiences this. In reality, it doesn't happen. This is happening because of the second law. Why? Because initially velocity of the lift is what? 0. And when it is moving in the upward direction, definitely if velocity is increasing, obviously acceleration direction is also in the upward direction. Yes or no? If I want to write the FBD on the person, normal will be acting in the upward direction, mg will be acting in the downward direction, acceleration is also in the upward direction. Yes. So if consider like this, here is the lift, and inside a lift the 100 kg man is standing, acceleration is in the upward direction, normal is acting in the upward direction, mg will be acting in the downward direction. If I ask you to write the equation, you will be saying n is nothing but mg plus of ma. Are yes or no? Bigger force n minus of mg is equals to ma. Directly there. So what is the relation between this? Now what is happening in reality? This normal is increased now. When the person is moving in the upward direction, this normal is increased. Similarly, consider here is the lift, and the lift is going in the downward direction. So acceleration is in the downward direction. Mg will be acting in the downward. Normal will be acting in the upward direction. If I ask you to write the equation, you will be writing that now mg will be greater now. Are yes or no? So you will be writing mg minus of n is equals to what? Ma. Or if I ask you mg minus of ma, that is nothing but your normal. Can I say that? Then again, normal. Yes, here also we are discussing about the normal. Yes, and when the lift is going in the upward direction, you feel heavier. And when the lift is going in the downward direction, you feel lighter. Yes or no? We are not discussing about the mass, we are discussing about the normal. That means there is a relation between normal and the weight. Normal and the weight. What happens in reality, let me tell you like this. Consider here is the weighing machine. Consider here is the weighing machine, and this is the display of the weighing machine. Okay. And consider 100 kg man is standing on this. 100 kg man is standing. We just now learned that weighing machine never measures the mass, nor it measures the weight. Then what does it do? Let us try to understand. Mg is acting in the downward direction. Obviously, normal is acting in the upward direction. This is the normal which is exerted by the weighing machine on the person. Similarly, this one person also apply the normal in the downward direction on the weighing machine. Okay. If I talk about only the person, then I will be writing that if the system is at equilibrium, that means A is equals to 0, then I will be writing N is nothing but mg. Are yes or no? That means mass is not changing. Mass it should not be changing, but when the person is moving on the lift, this mass is changing. Yes. So what is happening in reality? Weighing machine never measures the mass, neither it measures the weight. It measures the normal. It measures what? Normal, but it tells you the answer in terms of mass. That means weighing machine is measuring what? Normal, but it tells you the answer in terms of what? Mass. That means I have to divide this by G, so this G and G get cancelled. So weighing machine is measuring the mass and telling you the answer in terms of what? Mass. Weighing machine is measuring the normal and telling you the answer in terms of what? Mass. Got my point? That's the reason this normal is important. Okay, now let us try to understand. When you are going in the upward direction, this equation mg plus of ma, that's the reason normal is increased. If it is at rest, n is equals to mg. If it is at rest, n is equals to what? Mg. And when the acceleration is in the upward direction, n is equals to what? Mg plus of ma. And when the lift is going in the downward direction, normal get decreased. I got my point. This is what happening inside a lift and what is happening according to the weighing machine. So never ever say that weighing machine measures the mass or it measures the weight. Never. Weighing machine always measures what? Normal, but it tells you the answer in terms of mass. I got my point. So we know that normal will be changing. Mass never changes. That's the reason you are getting a variation in the display. Sometime 98 kg, sometime 100 kg, sometime 102 kg. This is because of variation in normal. Not because of mass. I got my point. समझ में आया ना रे? Condition number 1 or first one, point number 1, if acceleration is 0. If acceleration is 0, then can I say that whose acceleration is 0? Lift acceleration. Okay. If lift acceleration is 0, can I say there are two options, either the velocity should be 0 or either velocity should be what? Constant. Can I say that? Yes or no? Okay, now consider here is a lift and inside the lift there is a weighing machine, and on that weighing machine a person is standing. Okay, I am not going to take the values now. Now acceleration is 0. Acceleration is what? 0. Normal exerted by the weighing machine is in the upward direction. Mg will be acting in the downward direction. What will be the equation here? N is equals to mg. Why? Both the forces are equal. Both the forces are equal because of acceleration is what? 0. What you are getting normal here? Normal is what? Equal to mg. Normal is equals to what? Mg. Who measures the normal? Weighing machine. What do weighing machine is measuring right now? Normal, na? So this is the normal which is measured by the weighing machine. Then it is called as what? Real weight. This is what? The real weight. Same person is standing inside a lift. Consider like this. Acceleration is this time constant. And lift is moving in the upward direction. So this lift is moving in the upward direction, and this is the motion of the lift, and this is the direction of what? Acceleration. Obviously velocity will be increasing. Are yes or no? And consider the same scenario. Here is the weighing machine, and on the weighing machine there is a person standing. Obviously normal is in the upward direction, mg will be acting in the downward direction. Yes or no? If I ask you to write down the equation, you will be saying that normal will be greater, mg will be smaller. Why? Because acceleration is in the upward direction. So equation will be n minus of mg, which is equals to ma, or n is equals to what? Mg plus of ma. Mg plus of what? Ma. Can I say that from previous equation, that is n is equals to mg, this is your actual or real weight. From here, now the normal is increased by this ma. Normal is increased by what? ma. So whenever the lift is going in the upward direction and it is accelerating in the direction of motion, what I am saying, lift direction of motion of the lift is in the upward direction and acceleration is also in the upward direction and velocity is also increasing in the upward direction, then you feel some extra mass. You feel some extra mass because of this ma. Okay, now this is the normal which is now measured by whom? Again, weighing machine. It increases by how much? ma. Then this one is called as what? Apparent weight. Okay, this is called as what? Apparent weight. So can I say that Whenever the lift is going in the upward direction and it is accelerating in the upward direction, always the person feels heavier. Are yes or no? Now let us try to understand. If this is your S, then let me draw the situation like this. Same lift. Here is the weighing machine. Lift is going in the upward direction. This is the direction of what motion? This is the direction of motion, but velocity is decreasing. If velocity is decreasing, direction of motion is in the upward direction, definitely acceleration will be in the downward direction. This is the person what we are talking about, this mg, and this is the normal. Now who will be greater? Mg will be greater. Why? Because acceleration is in the opposite direction of what? Motion. Because velocity is decreasing. Yes or no? So if I want to write the equation over here, then I will be writing mg minus of n is equals to ma, or can I say that mg minus of ma, which is equals to n. Now can I say that this is the normal which is measured by what? Weighing machine. So this normal is decreased by ma this time. This normal is decreased by whom? Ma. That means weight is increased or decreased? Decreased. Yes. Why? Even though it is moving in the upward direction. Even though it is moving in the upward direction, but this time velocity is decreasing. So now tell me, can I say that whenever the lift is moving in the upward direction, the person always feel heavier? No. It depends on what? Acceleration direction. If the direction of acceleration and the motion of the lift both are in the same direction, definitely he will feel heavier. If the direction of motion is in the one direction and acceleration is in the opposite direction, he feel lighter. By what? Again the value ma. Okay, again this this is the weight which is measured by whom? The weighing machine. Again this one is called as what? Apparent weight. Okay, right on. Okay, shall I? So third, fourth condition. Again acceleration is what? Constant. Again acceleration is constant. This time the lift is moving in the downward direction. Here is the lift. This is the weighing machine. This is the person. This is the direction of what? Motion. So motion is in the downward direction. Okay. Now acceleration is also in the downward direction. So acceleration is in the downward direction. That means velocity is increasing. Velocity is increasing in the downward direction. Acceleration is also in the downward direction. This is the direction of what? Normal, and this is the direction of mg. Who is greater this time? Mg. So can I say that from here mg minus of n, that is equals to what? Ma. Okay. And if I rearrange this, n is nothing but mg minus of ma. Heavier or lighter? Lighter. Yes. Why? Because normal is decreased by ma. Now what is the situation here? Lift is going in the downward direction. Acceleration is also in the downward direction, even though he feel lighter. Okay. So can I always say that whenever the lift is going in the downward direction, he experiences lighter? Let us try to understand this by next situation. So situation number 5. So lift, and this is the weighing machine. Over here is a man. This time motion is in the downward direction. And velocity is now decreasing. Velocity is what? Decreasing. If velocity is decreasing, then acceleration is in the upward direction. This is the normal, and this is what? Your mg. If I ask you to write the equation, n minus of mg. So n minus of mg is equals to what? Ma, or n is nothing but mg plus of ma. Now normal is increased by ma, na? Normal is increased by ma. So can I say that always if the lift is going in the downward direction, the person experiences lighter always? No. It again depends on the direction of what? Acceleration. Even though lift is going in the downward direction, but velocity is decreasing. If the velocity is decreasing, obviously acceleration is opposite to the direction of what? Motion. Definitely the person feel heavier. I got my point. So never ever say that if a person is moving in the upward direction always feels heavier. No. If a person is going in the downward direction always feel lighter. No. It depends on the direction of what? Acceleration. I got my point. Right on. Okay. Now go to home.